Alright, this is a video tutorial to teach you how to use Google Sheets to analyze data in the science lab. We're going to be using Google Sheets to create a graphical model that visually represents the relationship between our two variables. And we're going to use that then to make a mathematical model that shows the relationship between the two variables. So let's get started. Let me give you some context first and kind of explain what the data we're going to analyze is for here. Someone was wondering if the amount of candy bars eaten each day affected the weight gained by an individual. So here is their data for that. Which one is the independent variable and which one's the dependent variable for that experiment I just described to you? Well, the experimenter is the one that chooses the value of how many candy bars are consumed each day. And then they're wondering if the weight gained each week depends on how many candy bars were consumed. So since they're choosing the values for this candy consumption, that's your independent variable. And they're wondering if the weight gain depended on it. So they're going to measure that during the experiment to see if it was affected. So that's your dependent. So independent here on the left, dependent on the right. If you set it up that way, with the independent variable on the left and the dependent variable on the right, Google Sheets will assume that that's the case, and it makes graphing a little bit easier later on. So I'm going to choose my data here to make my graphical model. Left click in one corner, hold that left mouse button down and select the entire region. And when you're ready to make the graph, you can come up here to that insert chart button, or if you prefer this, you go insert chart there. Either way gets you the exact same spot. Google Sheets throws a chart or a graph into your spreadsheet there, but it's totally guessing as to what type you want and all that. So we need to customize it for our particular uses. Here in physics, we're going to use not bar graphs and column charts. We're going to use what we call scatter plots. So up here is our chart editing window, and we can change a lot of things. I'll show you that in just one moment. I'm going to hit escape, and it closes this out. I just want to show how to get back into that to edit it later. If you simply double click on the graph, it brings that chart editor back up for us. So let's get started here. The data. We don't want a column chart. We want a scatter plot like I talked about before. So scroll down. You'll be tempted to pick line, but don't do that. We don't want that. We want the scatter plot. There it is. Choose that type. And then we can check here and make sure it's choosing the correct variable to put on the right axis. For the x-axis, it's choosing candy consumption. It's choosing that one. It's choosing the independent variable, which is what we want. We want our independent variable on the x-axis. And it's choosing the weight gained for our y-axis, which they're calling the series here. So that's why I put independent left, because it's going to default that to be the x-axis or the horizontal axis. All right, so we're good to go. Let's click on over to customize, because we do want to change some things about this graph. Like that's a really long title. I don't have any labels or titles on my horizontal axis and my vertical axis. So I need to do a couple things here. There's a lot of headings here. You can kind of get used to navigating that, but chart style, there's not really much you want to change for that. This one we do want to change a couple things. The chart and the axis titles. Let's drop that down. It'll probably default to that for you. The chart title, let's shorten that up. Candy consumption versus weight gain. Would seem to make sense for this one. See that changes that up there. Now let's change the horizontal axis title, because there's nothing down here now. We always want to make sure we've got axis titles. What's on that axis again? That was our candy consumption. Oops, having a hard time spelling here. Candy consumption. And the units of that would be candy bars. We always want to include our units on those axes. And you can see it populates that down there. Now let's set the vertical axis. And that was the weight gained, and that would be in units of pounds. So we've got all those titles now. It kind of gives meaning to the data. Without those, we're missing something. So let's get rid of that chart and axis titles. The series, remember the series is talking about these y or vertical axis values. There is one more thing we want to do there, but I'm going to come back to that in just a second. What I really want to do here is teach you one more thing about making graphs. We want this lower left corner of the graph to be 0, 0. We don't want it to be anywhere else. We're not going to be like breaks of the axes. If you remember that little jagged line type thing you've seen before, we don't want that here. Notice the vertical axis, the minimum value is 0, but the horizontal axis, 0 would be way back here. So I need to change that. So let's go to the horizontal axis, and let's set the minimum value to 0. If the vertical weren't already 0, I would do the same for that as well. Okay, so we're all set up. That's kind of our graphical model, but I do want to represent the trend here, or the relationship between the candy consumption and the weight gained. Well, a qualitative observation would be that as you consume more candy bars each day, you tend to gain more weight each week. Probably not a surprising result, but let's represent that a little bit better here. We're going to go into series, and I want to show a trend line, a line that represents it. If I check that box, it defaults it to a linear trend. Let's turn it off real quick. Does that look to be pretty linear? Or does it look to be maybe curved, like a quadratic function like ax squared plus bx plus c? To me, that looks to be pretty linear. So when I check trend line, it defaults to linear. I'm happy with that. If it looked to be a quadratic or something, I'd simply go into polynomial, and I could say it's x squared, or I could change it to x to the third. You can do a variety of things, but let's go back to linear, since that's what it looks like. So let's fit the trend line. So that right there really is my graphical model. Now what I want to do is get a mathematical model, or an equation that represents that line that seems to fit that data. I'll show you how to do that in just one second. I do want to mention one thing. Notice this line does not go through each data point. Real life data is not perfect. You're trying to find the trend that represents the relationship. So that line is representative of all this data, even though it's not going through the data points. It might not go through any of them. In this case, it looks like it goes pretty close to through that one and maybe through this one up here. Right, I'm just about done. The last thing I want to show you is how to get a mathematical model or equation for that trend line that represents the data. Still in this series thing, right after I check trend line, some other options appear down here. If you scroll down just a little bit, notice where it says label. If you choose label use equation, it puts it right here in the legend, or the key. That's really nice. So it's like y equals mx plus b. So y equals 0.531 times x plus, and then our y-intercept is negative 0.048. So that's the mathematical model for that line right there, which represents the data. Now we're going to have you change a couple things about this. We're going to have you change the y to what it represents and the x to what it represents, and put units on all these numbers. Okay, and we'll talk about that in class, but that's how this works. Good luck modeling with Google Sheets.